Well, welcome back, everyone. This is segment two. So if you missed segment one, make sure you go back and get it. Give you great context for the discussion I'm about to have with Sanjay Srivastava. He is the chief digital officer at Genpact. And we had an initial discussion around some of the technology, exciting technology that's coming down around big data and big AI in our first segment. So be sure to check that out. But now in this second segment, we want to dive into the challenges. Whenever you're introducing something new, there's going to be challenges, technology challenges, business culture challenges, all sorts of great challenges. And of course, a lot of external challenges that perhaps we didn't even foresee, that things are constantly changing around us in the environment. So we'll dive into a selection of those. But Sanjay, let's start off by just kind of brainstorming a little bit here about the top challenges with the application of large language models in the enterprise. What are you seeing?
Yeah, I think if you think about large language models, and we've now experienced GPT-3, ChatGPT, many of us have tried it out and played with it. One of the biggest issues is just the accuracy. And, we call this hallucination, which is, it is such a great language model that it says something so authoritatively and so, quote, genuinely, unquote, that if you were to just listen to it, you'd assume it's the right answer. But sometimes it may not be. And that's the hallucination. It'll sort of go off and create something. Could be completely fictional, but it'll make it appear like it's really real. Now, if you understand it, you can use it, right? Which is, you have to figure out where you use it, where you don't use it. And having a response that has some fiction associated with it may not be a bad thing. It could be a great thing if that's what you're intending to do. But being able to tell the difference is key. And this kind of is this whole idea of how do you take AI models from being directionally correct to specifically accurate, right? And the challenge there is we're on a journey of maturity. GPT-3 is trained for, I think we said in the previous discussion, 175 billion parameters, which is orders of magnitude higher than anything we've done before. But it's trained up to data that we knew to be true for last year. It doesn't know anything since then. So, for instance, we went to GPT-3 and it would tell you that Nancy Pelosi is still the Speaker of the House because it has not learned anything since when it was designed, since when it was put out. Now, in contrast, the work that Google is doing, for instance, I understand it actually goes and it can read the web right now and it sort of updates itself a little bit more. And so you're starting to see the advances. And of course, GPT-4, that when it comes out, is going to be a lot more up to date. It's going to be trained on many more parameters, 500 trillion, which is, you think about the size of the human brain, right? We have 500 trillion synapses. Some researchers would suggest that. Now, these are two different units of things we're talking about, but it gives you a sense for the magnitude of parameters that we're talking about, and therefore the implied accuracy and the predictive value that comes in. So it's definitely on a journey of getting to be more specifically accurate as opposed to just directionally correct. And that's the journey that you have to be thoughtful about. It's almost like you have to plot a curve that kind of lays out over time what level of accuracy you would expect for generative AI to be able to deliver. And then you have to think about your use cases. So in a large enterprise, the way you approach this is you think about that curve and you think about different use cases and you intersperse the use cases for the points at which they meet the curve. So directionally correct is actually great for many things, right? I work with a startup company CEO right now as an example, and they've been putting together an AI capability that allows you to predict when in a steel rolling mill, as the films of steel are being produced and coming off, one of the challenges you have is sometimes they'll sort of get wrangled and they'll start cobbling together. And so you don't get a thin film that you can roll up. You actually start getting kind of this messy thing. And when that happens, you have to stop the plant and fix the issue. And of course, that has a lot of waste on the steel itself. But more importantly, this thing is done at a very high temperature. So you gotta, everything cools down. They have to heat everything back up again. And the carbon footprint of having to go through the whole exercise is actually quite massive. And so what is key is you're inspecting that steel film, the films as it's coming off, and then being able to predict when this issue will happen. And if you can predict that, you can actually fix it while it's in motion. If you can't predict that, then you actually end up in a situation where you're shutting the thing down, you're cooling everything, you're heating back up again, you're increasing a carbon footprint. It's a complete mess, right? So there you need directionally correct, right? Because you know what? If 3 times out of 10, it gives me the wrong positive, the false positive. In other words, it tells me that a problem is going to happen, but it's not. I can just visually inspect it and I can let it go on. And so the cost of that false positive is very low for me, right? And so you have to think about use cases, and you have to think about when you apply AI or when you apply decision to the use cases, what is the manifestation of false positives, false negatives, and then think through that cost benefit trade-off, and then look at the accuracy curve and say, for where we're now today and the level of accuracy that we get, this use case is completely appropriate, and let's go forward. But equally, if you were to sort of fast forward and say, well, let's put something else in it and come back and make a stock recommendation for an investment portfolio completely automatically and just go and buy all those shares and put it in a client's account, well, maybe that's where we're not there. And so being able to pick where we are on that point in the curve, and then being able to think through, is this something we want to be directionally correct or specifically accurate? And then, if you will, thinking through business use cases and applying them at the right phases is where the key to success really lies. And companies that are doing that are really advancing the game in a way that's super differentiated. Companies that are not are either missing out on the action or actually coming with a lot of challenges that you now have to sort of work to fix. And so it's a really important thing to think through as you apply it.
Yeah, because you certainly want to be able to understand, what everyone's expectations are in terms of once you've got the result in front of you, what are you going to do with it, and is it something that's going to demand absolute accuracy or not? And so many of the decisions that, people make are, really actually become more creative when they are based on more of a kind of a fuzzy result as opposed to an absolutely accurate one, because the absolute accuracy might also even hamstring us sometimes and put us into a little bit of a straitjacket. And so yeah, I can certainly see how the importance of the use cases and thinking that through very carefully.
That's exactly right. And Derek, there's so many associated issues, right? One of them is explainability, right? It's a really important topic now on the table. I'll give you an example of a peer of mine at another corporation. He's got this challenge right now. They sell something, they sell a product. Each product will have up to 16,000 small components, a chip, a semiconductor, transistor, connectors, a bunch of things, right? But it'll be almost 16,000 parts. And when they sell the product now, more and more, there's a real, as we all know, there's a real focus on climate change and being green and transitioning to a low carbon economy. And so one of the requirements when you sell this is you actually have to provide the green score for that. And as you can imagine, the green score is basically the kind of weighted average of all of the things that went into that one product, and you have to sort of compute and represent that, and you have to do it confidently. And so the challenge there is you've got 16,000 parts. And if you think about, and this goes back to the big data discussion we had last time, when you think about it, that's a stupendous challenge, right? Because you have to take something, break it into its bill of materials, exactly for what went into that one specific product, right? And so you have to have full traceability of all of those 16,000 parts. You need to know where each part came from, by the way. And then you need to have the data from each of those providers for that little component. And then you have to sort of, you get the math, right? You have to weighted average all this out, and then you come with a score. And the challenge here is that when you've done all of this, by the way, and it's still a little bit of a guessing game just because it's so difficult to get data from all of these different providers and be able to keep it in a manner that you can actually compute this on the fly and create that green score. You do use some AI to be able to help you through that. But when you do that, you need to be able to go back and explain how and why you got those numbers. And this is why explainability is becoming more and more important. And it's a challenge, right? Because at some level, explainability has boundaries, no different than human decision-making has boundaries, right? If I asked you, Derek, as an example, you got up in the morning, you wore the jacket that you're wearing right now. Why did you pick the jacket? You'll say, well, I kind of like it. It's like, well, why do you like it? Well, and I keep asking a point, and then at some point you don't know the answer, right? And so it's this explainability, I think, is similarly a challenge for AI. And when you're actually representing things with a level of confidence, you have to be able to show it. And, we're working through it as an industry. I don't think there's great answers out there, but I think the best answer I've found is to get explainability to the same level as a human would have. And then at least I've matched what I'm replacing. And so if I go to a financial analyst and I say that you gave this, or let's say a claims professional in an insurance company, and said you gave this claim this response, and you start asking question of what was this about and this and that and the other, you get to a point where they say, I applied my judgment and this is what I believe to the answer to be. And if you can kind of, I think it's called breadcrumb. If you can breadcrumb your decision logic through to a point where it's very similar to how a human colleague would respond to it, then I think that's actually explainability that is similar. Now, I'm not saying it's 100% explainable, but it's similar to what you would otherwise get. And so anyway, explainability becomes a big issue, and it's something that we're all working on together as an industry, as a forum, and moving forward.
Yeah, no, that's a great explanation of it. The other thing that I was kind of wondering about, maybe you could comment on, is we talked about the maturity curve, of these capabilities, and right now, as we start, we understand that it's directionally accurate, and we want to get to a point where we can say, for the right use cases, we want to have specifically correct, returns. Now, how does one get to greater levels of accuracy? What does it depend on? What does an organization have to do to create that kind of maturity for those specific types of use cases?
Yeah, I think there's a whole organizational design, which we should talk separately about. But just on the AI front, what we're doing as an industry now is we're taking the advancing foundational models. By the way, foundational models, because they form the foundation for more things to come, right? So LLMs, foundational models, generative AI, big AI, very similar terms, if you will. So you take these foundational models and then you further train them for the domain you're in, right? And here's what I mean by that. So, and actually it's very simple. Even if you think about on your email as an example, you might start a sentence by saying, best regards, and it'll probably fill out looking forward to, and you can say talking to you or meeting you or something, right? So you can see how it kind of keeps filling out. And that's the case for, if you will, common English language or any language you're conversing in. These systems are actually very good.
Yep.
But if I wasn't writing an email to you and saying, hey, Derek, it's great talking to you, and I'm looking forward to seeing you next time, but I was putting something in a legal context, or I was writing, something around drug discovery and folding proteins together, or something that was very domain oriented. You can't just take, the email interface that you and I have saying, hey, it's great talking to you, I look forward to seeing you next time, and apply that to writing a legal contract or writing a footnote on a folding protein drug discovery paper. And so what you have to do is you have to take these foundational models, these all LLMs, GPT-3 today, GPT-4 tomorrow, etc. And then would you take that and then you actually train that further, and you train that on your data, on your ontology, on your nuances. You do a lot of reinforcement learning, so it learns further. And so the idea is you start with a much higher base than you ever had before, foundation models, and then you further train it for the domain, for the area that you want to focus on, and you allow it to become even more intelligent. And that's the journey most of us are on right now, because what we're saying is, foundational models are giving us a great place to start. Out of the box is delivering better performance than previous versions we've ever had before, including the ones we've trained ourselves, by the way. So most of my peers are throwing away 2-3 years of work they've done on training models, because the foundation models are actually even faster, better, more accurate, just coming right out of the box without any training. So it's foundational. And then what you do is you take that and you start training it for your domain, for your context, for the business nuance, for your ontology, for the things that you want to do with it. And as you do that, it becomes better, it becomes more accurate, it becomes more usable. And that's the journey you're talking about, which is, listen, GPT-4 and what is going to come behind that isn't here yet, but I've got use cases I want to use it for, and I can get great transformative value by being able to play. So what do I do? And that gap you fill by training these foundational models for your area. And that's the journey I think many of us are on.
Okay, yeah. Yep. Okay. Switching slightly, the other key thing that people have to think about is privacy. You mentioned it earlier as well. How do we go about avoiding privacy issues when we take this journey?
Yeah, it's a touchy topic because I'll tell you one thing: our norms on privacy are also changing.
Yeah.
So frontier. I look at my we have boys, and I look at their sort of notion of privacy and how much they're willing to share. I can tell you it's a whole lot different than me and the generation I grew up with. And so I think we have to kind of keep that in mind as we have this discussion. But no, it's a true issue. And it isn't just privacy, Derek, because it's much broader, right? It's security, because you've got all this data in one place.
Right.
You don't want to have a data breach. More importantly, now, it isn't just the impact to your consumers, which whose data you have, which is a big issue, by the way. So I don't want to minimize that at all. But the other problem with all of that is if you breach it and if you tweak it, the AI model is feeding off the data. And as the data drifts, the models will drift. So not only have you impacted the security of data that you originated from other sources and therefore compromised those sources, you've actually compromised the AI system itself because it's going to generate the wrong results. It's a big issue on the security side. Yep. Privacy is a large issue, not only because it's a super important topic, but norms differ by cultures and countries, and regulations are different. And so if you're a chief data officer, my God, I mean, being able to keep track of every changing rule and regulation and being able to manage an infrastructure globally. And, you realize IT originally was built on a foundation of leverage. So large corporation, you have a CIO or a CDO or a CTO. They're going to sit centrally wherever the corporate headquarters are or in some one location, but then they run a global infrastructure. And the leverage that you get around that is significant around cost of IT as a percent of revenue. And so you run a company that way. But now with different regulations and sovereignty rules and needing to keep data in different locations to comply with those regulations, you don't have the same level of leverage. You actually have lots of data sitting in lots of different places. And so it changes a little bit of the economic model as well behind it. So there's a whole piece there. And then I think beyond privacy, it comes down to ethics, and it comes down to intended or unintended, more importantly, biases that come in. Because it isn't just about the accuracy of the model. The reality is the model could be very accurate, but it's very accurate on the wrong data set and therefore gets the wrong results, right? So it isn't just accuracy, it's actually the ethics. And did you train it in the right way? Did it not drift from what you intended it to be? And therefore, is it applicable to the task you're putting it to in a very inclusive, proper fashion? Mm-hmm. The world's changing, right? And one of the biggest things I see, and I'll take the pharmaceutical example because we can all relate to it. When drugs get discovered, they have to go through a safety and a trial mechanism, right? And the old way was we'd actually pick one location, pick Scottsdale, Phoenix, and then kind of bring a trial, a new drug trial there, and we kind of host a facility and set up the parameters and invite people from the local community, and you have a sample size that was appropriate. But you know what? It would be the demographic representation of Scottsdale, Arizona. I'm just picking an example. It would be very localized to that. But when the drug comes out, it's applicable to the whole world. It's applicable to different demographics. It's applicable to different sort of types, if you will, of ethnic origin, of other demographic characters. And so how do you make that more inclusive so that more people include in the test? And how do you make it more equitable? Because when you come up with it, address everyone, let alone how do you make the drug better because it's now applicable to a much larger cross-section of society. And so as we shift from this kind of physics of localizing it to using AI and knowledge graphs and virtualizing this and being able to spread it over a distributed system, you can access a much larger footprint of humanity. You can actually get data points that sit all over the world. You can actually run this in a virtual fashion using knowledge graphs and AI to be able to spot the challenges or the safety issues you're going to have. And it just completely changes the game. And so my point is, we're doing this for a reason, because it brings so much value and it changes the way the game is played. It makes, in this case, everything more inclusive, much better. But at the same time, you virtualize it. You've got all this data sitting in different locations. You actually have to manage all that, and you have to make sure that your usage is intentional in the areas that you were permitted to use it for. And this permissibility is a big issue as well, because what's happening is, look, most of us have data that comes from physical sources. So you'll come into my retail store, you interact with me, you buy the suit, and I know the jacket, and I know the tie you'll most likely buy next time. That's all physical retail data. You'll come in digitally into my e-commerce website. You'll interact in many different ways. And when you do, I'll know that you are the same Derek that actually shopped in the Los Angeles store. And I should be able to compute that you bought the blue jacket and you probably need this other tie, et cetera, and be able to give you a seamless experience. And more, we're now getting into the metaverse, right? And you might interact in the metaverse with a set of things. And so you're the same identity, whether you're in the metaverse, whether you're in the physical verse, whether you're in the digital verse. And you have different ways you've interacted with it. And being able to seamlessly context switch and be able to understand that you did something here and therefore you need this other thing here, and then that correlates to the metaverse in this way, is actually tremendous value added to you. It's tremendous value added to me as a business. But to do that, I have to be able to understand that you're all three of those people at the same time and be able to correlate all that information. And so the flip side of that is, now when you think about privacy, I know everything you're doing physically in my store. I know everything you're doing digitally in my store. I know everything you're doing on any metaverse, things that I have. For instance, today you can go in the metaverse and you can design your own jacket. I can design this jacket. I can brand it as Sanjay's jacket. I can own the IP of this jacket, and I can show up in a store and basically say, I want you to stitch the jacket in the color and the fabric and the cut and the stitch that I designed. It's called Sanjay, and deliver it to me. So you can see how it's the metaverse, it's the physical verse, it's the digital verse all coming together. And being able to manage all of that is a cumbersome task because there's different permissions associated with it. You can imagine, right? You go to a store, it's a very different level of permission because I've already seen you. I know your face and exactly who you are. When you come into my digital store, actually, when I come into your digital presence, I don't want you to know who I am. I don't want you to be able to see my face. I might be in my pajamas. I'm not in my jacket. And so I don't want to have this interaction. When I'm in the metaverse, I have an avatar. And so you see how we have different personas and different ways we interact. And yet on the other end, we want to be able to understand all of that. And that takes a lot of effort to get right. But more importantly, once you get it right, it takes a lot of effort to manage the privacy, to manage the ethics, to manage the intentional use, and to be able to govern it ethically going forward. And I think that's what we're all working through.
Yeah. No, great context, Sanjay. Thanks for that. I mean, there's incredible opportunities that we faced with data and AI, but there's a whole bunch of challenges, and it's certainly not something, and I think you really brought it out well, it's not something we can just lurch uncontrollably into, and hope we're going to be successful. It's something we're really going to step back and say, okay, well, what are we really wanting to do here? And let's do things in the right sequence. Let's do the right things for the right reasons, et cetera, which really starts pushing us more and more into kind of, okay, what's our strategy like? And that, by the way, is the subject for segment 3. We're going to dive into, data-driven business strategy and culture type discussions. And I think we've kind of teed it up nicely in this segment. So thank you very much for that. And hey, listeners and viewers, make sure that you catch segment 3. We're going to wrap this all up with a discussion around, strategic and cultural type issues.